All right, I'm back to look at a couple of trouble questions from the set 31 through 40. The first question you seem to have some troubles with was number 34. So in this particular problem, it gives us the ratios for the sides of a triangle. Right here is the ratio for one particular triangle. If you really wanted to, you could draw a picture of this. All this is telling you is that the shortest side of a triangle would have to be 12, the next longest side would have to be 14, and the longest side would have to be 15. We don't necessarily know the shape of the triangle. We don't know if it's going to be a right triangle or a acute triangle or a obtuse triangle. We're not too worried about that right now. What it tells us is that in another triangle, the shortest side would be 8 inches long. And we want to find the length of the longest side. Now, you could use this picture right here to complete this, or you could just use the fact that in our other triangle, the shortest side, which corresponds with 12, would be 8. We don't care about this middle at all, and the longest side is x, which we're trying to find. So we could use this information, 12 and 8 and 15 and x, to set up a proportion, or we could do it from this diagram. So based on this, we could say 12 is to 8 as proportionally 15 is to x, which is the ratio of the longest sides. And now we have a proportion to solve. We cross multiply. 8 times 15 is 120, is equal to the cross product here, 12x. Divide by 12 on both sides, and x would have to be 10. So the answer to this problem is B, which is 10. Again, we don't really need to waste our time drawing these pictures. We could simply just use the fact up here that we know the shortest side, 12, has to correspond to 8, as the longest side, 15, corresponds to our unknown value, x. So from this information right here, we could set up this proportion and solve. All right, the next question I want to look at is number 38. This simply has to do with the distance formula. The distance formula in the coordinate plane says that the distance between 2 points is equal to the square root of x2 minus x1 squared plus the difference of subtracting your y values squared. Now, if you remember this formula, great. This is probably the one that you want to memorize. It's one of the recommended formulas to memorize before your test. So if we would do this, the distance between these 2 points, we're going to subtract the x values. So we're going to take 1 minus 0. And we're going to square that. And we're going to add it to the result of subtracting the y values in the same order. 0 minus 5 and squaring that. That's going to give us the square root of 1 squared plus negative 5 in parentheses, careful there, squared, is equal to the square root of 1 plus 25, which is equal to the square root of 26. So the answer here is E, using the distance formula. Remember, when using the distance formula, you can subtract your x values and subtract your y values in any order as long as you remain consistent. Your answer would still be, if you were to do it this way, square root of 26. Another way to look at this, if you were really struggling to figure out how to do this, is to draw a picture. The first point is at 1, 0, which would put us over 1, up 0 on the x-axis. And the other point was 0, 5. So up 1, 2, 3, 4, 5 on the y-axis. So basically, we could draw a triangle right here. And we can see that this side is a measure of 1. This side has a measure of 5. And we could use the Pythagorean theorem. 1 squared plus 5 squared is 26. We square root that to come up with this remaining side. So Pythagorean theorem is one way. I would highly recommend that you remember, jot down, keep this distance formula in the back of your mind. Subtract the x value squared plus subtract the y value squared to find the distance between 2 points. All right, the last question, and probably maybe the most valuable one I've looked at since the beginning of this course, is number 40. This has to deal with circles. I'm not sure if we spent a lot of time talking about circles in math, but the basic form or formula for the equation of a circle is x squared plus y squared is equal to the radius squared. So if I had a circle centered at the origin, centered right in the middle like this, and I had a radius of 1, 2, 3, so from center to the outside, I had a radius of 3 as I've drawn there. The equation would be x squared plus y squared equals 3 squared, which is 9. So this equation would be that for that circle. Now, just like doing transformations of graphs, if we take this and do x minus h squared plus y minus k squared is equal to r squared, these values inside the parentheses for h and for k are going to determine the center of the circle. So like the other transformations we've learned about in class, if this transformation happens on the inside, it's going to move it left or right that many values. Again, if it's -5, it's actually going to move to the right. If it's -6, it's actually going to move down, etc. So it's backwards from what you'd think. This value in here determines left or right, and this value in here determines up or down in this particular case for a circle. This is also going to be backwards from what you would think. So in this particular question, what it asks us is it says we have a circle tangent. That just means it's touching at one point. It's touching the x-axis at 5 and the y-axis at 5. So to draw a picture of this, we have 1, 2, 3, 4, 5. This is our tangent point on the x-axis, and 1, 2, 3, 4, 5. This is our tangent point on the y-axis. So this equation is saying that we have a circle. It's going to touch one time there and one time there. So our circle is going to lie in here someplace. Can only hit one time at those points. Not drawn perfectly, but I think we get the idea. So we got to come up with the equation for this circle. Well, in this case, the center is going to be here and here, and that point for the center of the circle is going to be 5, 5. So the equation of this circle is going to be x minus 5 squared plus y minus 5 squared is equal to the radius. The radius from there to here would also be 5, so we take 5 squared and we get 25. So remember, in parentheses, the -5 actually moves it to the right 5, and the -5 inside here actually moves it up 5. Backwards from what you'd think because these are inside the parentheses. So any transformations inside the parentheses are backwards from what we might guess. Any transformations outside follow what we might guess. So the correct answer to this particular equation would be x minus 5 squared plus y minus 5 squared equals 25, which is D.